Dear students, we will go to the explanation, the program explanation part of the experiment 2, that is polynomial addition using arrays. Okay, here you are going to use the header file, that is hash include stdio.h. You are going to include your header file here. Then you are going to create a polynomial of a data type structure. That's why you are given struct poly, and it includes two data members, that is int, coefficient and exponent, because a polynomial will have two terms, that is an exponent part and a coefficient part. Okay, here the next line, you have given struct poly p1 of 10, p2 of 10 and p3 of 10. You are going to create an array of polynomial structure. Okay, so that's why you have given p1 of 10. P1 of 10 is used to represent the first polynomial, p2 of 10 used to represent the second polynomial, and the two polynomials you add and you store the result in the polynomial 3. For that only you have declared p3 of 10. Okay, and you have three functions here: read poly, add poly and display poly. Read poly is used to read a particular polynomial input from the user, and it will take only one argument here. And the next one is add poly, the function which is used to get the two input, which will have the two polynomial inputs as well as a polynomial to store the result. Okay, two polynomial arrays you are going to give as an input to the particular add polynomial function, and you need one more polynomial to store the resultant value. Okay, polynomial structure to store the resultant value. And if you take the display function, it is used to display the particular polynomial to the output to the user. So that's why you have used void display poly. Okay, and if you take the main function, you have declared three integer variables t1, t2 and t3. These variables are used to whenever a particular function like read poly, add poly and add poly, etc., they are going to return some value to the main function. For that value to be returned, you are going to receive in this variable called as t1, t2, t2 and t3. Okay, so if you take the t1 equal to read poly of p1. So read poly, it is a function call here. You are going to call the polynomial, you are going to read the value from the user. So read poly of p1, automatically it will come to this function definition part here. So what is the function definition part? You are going to get the input from the user. Okay, so you are using two variables here, t1 comma I. So you are asking the user to enter the number of terms in the polynomial. You have used a printf. Printf, enter the total number of terms in the polynomial. You are going to read it using scanf. Scanf %d address of t1. Next, you are asking the user to enter the coefficient and exponents in the descending order. That is, if you have if the particular user has entered the number of terms as 3, this particular row will be executing for that many number of times, 3 times. Okay, the same way here you are going to, this for loop is used to get the coefficient and exponent of the particular polynomial in a descending order. Okay, so here you are going to ask the user to enter the coefficient value. You are reading using scanf. Again you are asking to enter the exponent value. You are reading using scanf. Okay, so like this you are going to, if the particular user enters the number of terms, that many number of times the particular coefficient and exponents has to be read from the user. So for that only you are using this for loop. Okay, so after which you come to the main function. Here you are just displaying the polynomial just using printf. First polynomial, you are displaying the polynomial p1. So for that you have written a display function here. So what does this display function is used? It is used to simply display the polynomial to the output screen. For that you are going to have a loop variable k. Then for k is equal to 0, k less than term k plus plus, because in number of terms is, that is the number of times your particular polynomial has to be printed. Okay, so that's why you have given k is equal to 0, k less than term minus 1, k plus plus. You are going to display printf %d p of k dot coefficient comma p of dot k dot exponent. Okay, so you are going to print the coefficient value and the exponent value until the number of terms k less than term minus 1 is satisfied. Okay, then you are going to go to the we will also similarly read the second polynomial using t2 equal to read poly of p2. How the same way how you read the first polynomial, the same way you are going to read the second polynomial, and you are going to display the second polynomial using printf. Second polynomial is display poly of p2 comma t2. Same way your polynomial p2 also will be displayed, because already we have seen what is a display function is. Okay, next you have the third function, that is the add poly function, which is used to add the two polynomials and store the result in the third polynomial. So what you are going to do is that in the add poly function you have three loop variables I, j and k. So I is used to represent, and it is used as an index to point the first polynomial, j is an index to point the second polynomial, and k is an index to point the third polynomial, that is your resultant array. Okay, so you are going to check when the two polynomial terms are equal. രണ്ട് polynomial terms number of terms equal ആവുമ്പോൾ you have the following three cases which we discussed already in the class. That is, this three cases has to be checked. That is, if the two polynomial exponents are equal, what you will do, you simply add the coefficients and you store in the resultant array. Similarly, you add the simply assign the exponent as it is. So for that only you have written this step. P of 3 of k dot coefficient is equal to p1 of I dot coefficient plus p2 of j dot coefficient, and p of 3 of k dot expo is equal to p1 of I dot expo. So you are adding the two coefficient value, storing in the resultant k dot coefficient. Similarly, we are assigning the exponent value to the kth exponent. Okay, and suppose if the second case is that if the polynomial p1 dot exponent is greater than polynomial p2 dot exponent, that is when you compare the two polynomial, first polynomial the exponent second polynomial കാട്ടിലും greater ആയിട്ടുള്ളപ്പോൾ what you will do, you simply assign the coefficient of the first polynomial as it is to the resultant array and the exponent as it is to the resultant array. So that's why you have given this statement, p of 3 of k dot x coefficient equal to p1 of I dot coefficient. Similarly, p of 3 of k dot exponent equal to p1 of I dot exponent. Okay, this is the second case. Else, that is, you have incremented the value of I and you have incremented the value of k. Okay, else, what is the third part? If the second, what is the third case? If the second polynomial is greater than the first polynomial, okay, what you have to do? You have to assign the coefficient part of the second polynomial to the resultant array. So that's why I've given the statement p3 of k dot coefficient is equal to p2 of j dot coefficient, and also you assign the exponent value to the resultant array as it is. So p3 of k dot exponent equal to p2 of j dot exponent. You are incrementing the value of j and you are incrementing the value of k. Okay, now if both the number of terms in the polynomial are equal, you go for checking of this three cases. Okay, but when there is a term in p1 and when there is not a term in p2, or when there is a term in t2 and not in t1, you will go like this. Okay, while I less than or equal to t1, when there is a term in p1 and not in p2, what you will do, you simply copy the same term into the resultant polynomial. For that only you are using this while loop. While I less than t1, p3 of k dot coefficient equal to p1 of I dot coefficient, and p3 of k dot exponent equal to p1 of I dot exponent. Okay, and similarly you are incrementing value of I and k, and when there is a term in p2 and not in p1, you go for this case, that is p3 of k dot coefficient is equal to p2 of j dot coefficient, and p3 of k dot exponent equal to p2 of j dot exponent. When there is a term in p2 and not in p1, you simply copy the term from p1 to the resultant array. Okay, so for that only you are using this particular set of statements, right? and finally you're returning the value of k, which will be received to this main function. That is, you have called here t3 equal to add poly of. So after the particular execution of this add polynomial part, it will return to this place in the main function. Finally, you are going to print the resultant polynomial after addition. For that, you are going to use a display function. Which polynomial you are going to display? Polynomial p3 comma t3. You have added the two polynomials and you have stored the result in the third polynomial. That is the polynomial which you are going to display, right? So this is the execution of your, or the working of your polynomial program. Okay, if you have any more doubts, you can just ask your faculty assign, okay, or even you can ask during my class time. Okay, thank you.